We have just heard this morning, and I hope I take it right, as we are all together with that community for the next 40 years, working on a city that can accommodate 1 million people more or less every week. So the urbanization goes on. We have passed the 50% marks. Back in 2011, we had more than 776 cities with more than 1 million people, and whereof 280 of them that time were located in China. What does that mean for us? If we look at the vertical transportation, elevator systems, looking at the commercial building, they do take a share of up to 10% of the total energy consumed. If we talk and look then more at residential, high-end residential buildings, it can even go up to 50%. So I would like to invite you to a little journey how Schindler addressed that topic over the past years, how we were able to put concepts into practical usage. All started back in 2011 with the CTBUH conference in Korea, where we were planting the seeds to launch a new destination control technology, and we were starting to look at how can we make sure people touchlessly, without pushing buttons, enter a building and are going to be served to their destination floor. The story went then on in 2012 back here in Shanghai, when we started to look at, together with the Congress here, at vertical cities. Vertical cities, we looked at mixed-use buildings. We started to map the segmentation of office, hotel, residentials, but we also started to really, truly understand what are the different needs of the users in those segments. And obviously, we worked on adapting the elevator technology towards the human behaviors to make that all work. Went then on to London last year. We pushed that concept a step further by looking at the users and their habits. And at the end, how do those habits influence the development of elevator technology? So it's more the user now in the central point, really providing us the inputs, how we can make that better work. Very glad to be here back today, back in Shanghai again, talking about sustainable vertical transportation with the evolution of green technology and maximizing the potential of destination control. As a truly Swiss company, I cannot avoid, making a link to our lovely Swiss watches. As you have seen, the topics we went through over the past years at the conferences, they are quite nicely linked together like gears in a Swiss Rolex. Nevertheless, developing a tree always starts with understanding the need, the market, the users. So that's what we have done when I talk about concepts. So we looked at the basics to understand how to develop. We talk here about high-rise. So we went through a lot of field testing. You will see later on what I'm talking about today is not just a concept on the paper. We learned a lot, and we try to develop further and to improve. We went through the implementation stage, and today are demonstrating how concepts are put into practical usage. How do we look at green today? I'm sure that most of you are familiar with all those more green marks for buildings. If we look at LEED or BEAM or the Green Building Council, these are marks for buildings. And there is still, in my opinion, a downside that the vertical transportation is very little linked to the rating the building at the end of the day achieves. To make that whole story of my speech a little bit more visible, I split it into 3 sections. So we have a short start with certifications, go then into elevator configurations, and are ending up with the elevator usage. So if you look at the certification, Schindler has been heavily involved in working on developing a kind of standard we can altogether measure the efficiency of an elevator system. What we look at here is the VDI 4707. that is quite widely recognized now, used in the elevator business, and gives us an idea on the system. There remains a concern, as this is really a snapshot on one elevator system, but it doesn't yet reflect and build the bridge into the real usage in the building. So we can here altogether make sure that we deliver the right things, or the customer pulls the right stuff from us as elevator companies, but we cannot really give him a lot of information if we want to talk about operational costs later on and the impact on the operation of the building. We have been investing years into a tool platform where we are capable to do traffic and energy simulation. How do we do that? It's now meanwhile built on more than 7,000 installations out in the field, where we are able to access the buildings once they are in operation, really learn what happens there, learn whether our assumptions were right or wrong, and build a tool that we can, when you start to design a building tomorrow, provide you a simulation how closely it's going to look and work the years later when it's put into operation. Also here a concern, as we do not yet have an industry standard on that. This is more related to every individual elevator company. Stepping into elevator configurations, and I'm aware that there are plenty of experts here in the room, but sometimes I think it makes sense to go back a little bit to the basics, as we are all love to talk about the future. Sometimes with our customer forget to make sure they understood about to get the basics right. So if you look at drive systems, obviously, we do need outstanding inverter drive technology. We do need to deliver outstanding recuperation modes. We do have highly efficient gearless and permanent magnet machines. All those, at the end, generate from the technology and design side green credits towards our customers. If you look on the control side, highest traffic performance with destination control, reducing the operation of empty cars, adding wherever it's possible automatic switch-off functions, reducing the standby energy, and a new feature I'm going to elaborate a little bit further later on is this so-called eco mode that we are now, after quite a long testing phase, having put practically into the markets. If you look at doors, obviously high-efficient door motors as well here, and wherever it's possible, less friction mechanics. If we look at car and hoistway, also here, we provide automatic switch-off functions. LED lighting technology, it sounds so obvious. Do we not face sometimes the loveliest buildings, and what they put in the cars in terms of the lighting has nothing to do with being green, and the use of very highly efficient roller guides. So this is a snapshot about technology and design that contributes to green credits. We all agree that the elevator control is most vital to get the elevator run up and down. But we understood years ago that there is far more behind, because the only way we can access further information on what happens in the building is the link through the elevator control. If we look back here, elevator industry started with conventional control systems. We had one button, then obviously we were able to understand whether the people want to go up and down. In the early 90s, we put the first destination control on the market. And not only did we enable designers to build higher because we could boost the efficiency of the elevator system, but more, we also started to understand to where the people would like to go before we serve them. A few years later, we added access control, means we individualized in a way that we didn't only know where they want to go, we are able now to understand who is behind the call and where do they move and how many times they move inside the building. We moved on with the latest development, port technology, where we added additional features in terms of we know who they are, now we can communicate with them, and we can leverage all that information to the topic of today, also transforming it into additional energy features. I'm sure I'm not going to explain that to you guys about what recuperation means, but to have a complete story today, that's how we all understood how it works. We do have in high-rise buildings quite a significant time where we consume energy, and we do have situations in the building where we are able to feed back in terms we are in regeneration mode, and depending on the building, the type, the amount of elevators, we are able to contribute up to 50% of clean energy with less distortion as possible back to the mains. As we are at the Tall Building Conference, allow me to show this page here. As we all understood, buildings evolve over the time, they get taller and taller, and there is a direct proportion between building height, elevator speed, and the energy saving potential we can generate. And more the message on we have to get those tall buildings right, because there we have the most of the potential to contribute to sustainable vertical transportation. Nevertheless, it should be a message that later on is also broken down and at the end implemented in every elevator that is put on the market going forward. Now, high-rise buildings, for whom do we design them? Who is going to use them? So let's switch after a short snapshot on technology, more on the humans who do use the elevators. It's not only use them, I can tell you it's making sure they use them properly. We develop stuff, great ideas. We learn that, people misuse it. And I think at the end, it's all our aim to have systems that are properly used. Only then we can benefit most and really take it back into further development. That's a daily situation in any high-rise buildings. The buildings fills up, people are entering in the morning, people go out. Very, very commonly used. So we start normally with a lobby. We have a few people early morning entering. It fills up then a little bit. During up peak, it gets very, very crowded. And the truth at the end of the day is that it is empty and it can be very busy. And the fact at the end is that this is very real and this is very dynamic. And we cannot to 100% influence that, but the key is to understand what happens in the building, because then we know how we can further optimize our systems and really generate further benefits. If we looked at such buildings, we stepped then back and said, okay, what to do next? So we looked at performance versus further energy-saving potentials. And not saying like, that's a mode you can switch on. No, in a way that we look at how can we balance and customize that for any of the buildings. We call that whole development where we have a self-adjusting elevator system that understands I have a low demand or I have a high demand. We manage with the Schindler so-called eco mode. Let's look back how that works. We just take a building, there is a traffic, a few elevators go up, serve people, a few elevators go down, serve them downwards. We do have the eco mode in place now. The first thing, recapping a little bit, port technology, and we can simulate. Simulate not only when we do the design, no. Now we have people inside the building, so we can take the data feedback and really compare now the beginning when we started to design with the investors versus where we are today. We call that this intelligent monitoring of the traffic flow. Once we understood this, we can go further and say, now the option is to talk to the investors, to the building operators, and say, we do have now opportunities to go further by balancing the performance you contribute to the users, to the tenants, versus additional energy-saving options. Making that a little bit more visible. Let's assume we have heavy traffic in the building. Always assuming that together with the owner, you set a standard. The first standard could be set during the design of the building. Is it a grade A? Is it a grade B? So this gives a certain indication where the performance of the elevator system is supposed to be. Now we can go a step further with the owner and talk about, look, that's how the building works now. And by switching this or the other function on, you can further optimize. Always taking as the assumption that we are within the range as an example of a grade A office building. So, high traffic, so what we do, we cannot really benefit much further because during heavy traffic in the building, our biggest aim is to move the people as fast as possible to their destination. So we need quite a high demand on energy because it runs full speed and we have a reasonable waiting time within the performance range set. Up-peak traffic passed, we have a building that operates, a few people go down, a few people enter. We call it, we can get into a modest stage. So we can start to optimize and whenever there is an opportunity that we can serve the people within the predefined range, we are going to put elevators on sleeping mode or standby. So what you will experience as a user could be a little bit more waiting time, but for the building we start to generate additional savings on the energy consumption and can then go to a full mode. That happens when in the evening after 5 o'clock the building is, getting emptied, where we go with a full mode, have full focus on generating the energy and increasing the waiting time a little bit further, still serving the tenants to their full satisfaction. We talked about a lot of, things now. Let's take one case study of a real building that has been measured. It's an office building, around 200 meters, 3 zones, quite typical. It has around 4,500 tenants. It has a low zone with 3.5 meters per second. It has a mid zone of 5 meters and a high zone of 6 meters per second. The measurements here are based on an average of 400,000 trips per year as a baseline. So when we looked at traditional elevator technology, 8 car groups for low zone, mid zone, high zone, you see the yearly consumption is between 160 to 388 megawatt hours per year. Now, as a first step, we put on recuperation drives, still keeping the conventional control. So we already end up here for that case with 42% less energy consumption. Looking back what we talked about now with port technology, we put the latest destination control plus all the optimized functions out of the eco mode. And you will see at the end of the day, optimizing the groups, adding performance, adding features, we are able to operate the building with 1/3 of the energy we would have still used a couple of years ago. How these benefits customers? All of us, we call ourselves to the high-rise community. First, the users, less waiting time, faster journey to their final destination, seamless, less frustration. If you look at the building owners, obviously, it's the reputation of the building. I'm not staying here today and saying that's the feature and all that for every single building. We are talking here about high-rise, high-end, buildings that are put on the market. It adds value to the asset to keep the building sustainable over years. It adds to lower operating costs. Hopefully being able to continuously invest into that building, when we talk then after a couple of years on modernization. But most importantly, it also is important that we understand what is our role we play as elevator companies to provide whatever is possible to reduce the carbon footprint. We talk here about sustainability, and I'm sure that you all share with me that sustainability starts with everyone's responsibility to continuously work on what we can add on here. How do we support you? It starts in very early stages. And you know, every year the conference starts, every time we have an opportunity to talk to investors, to consultants, let's start to talk with each other in very early stages. Get elevator companies involved when you have an idea about a future wonderful new high-rise, because that's when we can together influence and make sure we put the right stuff into place. So it starts with the traffic planning. It starts already then talking about how we simulate on operational costs later on, and hopefully developing further on how elevators are more recognized also to the green certification of the building. Once that is done, we are entering the construction mode, the installation also of vertical transportation medias, where, as I just explained, you know, obviously we deliver the material, but we start to understand how that works now in that specific building. There is not one single rule for such high-rises. We have to learn together, we have to analyze the data, and we have constantly to monitor and improve. But that's not when we should stop, because the building now is going to be in operation for the next 20, 30 years. So the cooperation between all of us continues throughout the journey of the operation of the building when we talk about upgrades, modernization, and maintenance of the elevators to keep that building really up to the standards that are constantly evolving.